All right, I'm going to show it both ways again here. Okay, so I'm going to move a little quicker, hopefully. Suppose average pizza delivery times are normally distributed with an unknown population mean. We don't know what mu is. Again, we wouldn't create a confidence interval for a population mean if we knew what the population mean was. We don't know what that is, but we do know the population standard deviation. Sigma is 6. A random sample of 28 pizza deliveries, that's our N, is collected and has a sample mean delivery time of 36 minutes. That's our X bar. We want to find a 95% confidence interval, 0.95 confidence level for the population mean delivery time. All right, so again, the interval we're looking for is X bar minus E to X bar plus E. Okay, we need to find the error bound in order to calculate this. And the error bound is the z-score for that specific confidence level. That's that sub alpha over 2. It's not an X. I know when I write it small, sometimes it looks like an X, but you zoom way in, that's an alpha. All right. Sub alpha over 2 times sigma over the square root of N. All right, that's our error bound. We need that error bound in order to find the confidence interval. Okay, let's remember what the z-score is. If confidence level is 0.95, that means alpha is 0.05. Alpha over 2 was 0.025. That's the percentile we would be finding. We already have this z-score. It was the first one we did together. Okay, so if you don't remember how to do that, or you're still not sure how to do that, go back, 2 pages, and go over this example again. I don't remember how many videos that is ago. All right, but that z-score was 1.96. Sorry, I'm giving some of you vertigo here. I'm jumping all the way around. I apologize. All right, it was 1.96. So the error bound is equal to that z-score times sigma over the square root of N. That was 1.96. Our sigma was 6 divided by the square root of 28. So my error bound, let's go to our calculator. Let's type this in. My error bound is going to be 2.2224, rounded to 4 decimal places. That's my error bound. Now for my confidence interval, I subtract that from X bar and I add that to X bar. My lower bound is going to be, in this case, 36 minus 2.2224. I guess I'll actually write out what that equals. All right, let's go back to our calculator. If I subtract, that's 33.7776. If I add 2.2224 to 36, I get 38.2224. So my confidence interval is 33.7776, comma, 38.2224. Again, if you're feeling really confident with this process, you know how to do it by hand, you can use the online calculator. All right, the online calculator does not show you what the error bound is. All right, we would be selecting that we know sigma because they gave us the actual sigma. We had an N of, oh, don't do this to me. Dang it, it does this to me sometimes. Let's see if I can write it in. We had an N of 28, nice. We had an X bar of 36. We had a standard deviation of 6. Sorry, I have the notes closed. 6, and we had a confidence level of 0.95. Let me try to do it on the, there. Good, I clicked calculate and we see 33.7776 and 38.2224. That last value would be rounded to 4. All right, again, make sure you know how to do this by hand. If you are confident that you can do it by hand, you are welcome to use that online calculator to speed up the process as you do more examples on your homework. Before we wrap up this video, let's write a summary. All right, I showed it both ways now. One option for a summary is we estimate, and I'm going to keep it very generic, only fill in the pieces with 95% confidence, 95% confidence interval. When you write a summary, you need to include what percentage, how sure are you? And that depends on what you used when you calculated that error bound. All right, we estimate with 95% confidence that the population mean delivery time, pizza delivery time even. So you need to include context there, is between, and here's where we can round, 33.78 minutes and 38.22 minutes. Make sure you include your units on those 2 times there.